IT Service Delivery and Support, Part 2. You know, it seems like through this entire CISA series, we've been dealing with a lot of concepts, methodologies, techniques, approaches, systematic designs, and solutions. Almost a logical and philosophical approach to this. And you know what? You would be right in making that conclusion. But now we're going to kind of shift gears a little bit and look at the kind of things we actually get to put our hands on as auditors. When we go into an organization and we evaluate its service delivery and support, we have to get right down to the hardware level. So if we relate back to the OSI model that we talked about in the previous Nugget movie, we're going to start really looking at some of the things, some of the components and the hardware and the software that actually reside at those different layers. In Part 2, we're going to conquer 4 key knowledge areas. We're going to look at information systems operation, information systems hardware, we'll talk about hardware management, and then we'll finish up looking at IS architecture and software. Auditing the delivery and support of information systems operations is going to involve several key functional areas, and it wouldn't hurt to jot these down. We're talking about the overall management of the information systems operations, the way that computers operate, the help desk, technical support solution, scheduling for systems operations, controlling I/O and processing, quality assurance and quality control. It includes assessing configuration management software and techniques, procedures for problem management and incident response, as well as the monitoring of efficient and effective use of all the resources. It also includes physical and environmental security management and informational security management. ITSM is an approach that's based on the ITIL, Information Technology Infrastructure Library framework, which was formed by the United Kingdom and demonstrates industry best practices, processes, and procedures for information technology. As a matter of fact, the ITIL has its own certification process, and CBT Nuggets will be delivering Nugget movies for this certification in the future. To guarantee service levels for internal standards or for service level agreements with vendors and partners and customers, we've got a variety of service level tools. Remember, information services is primarily there to meet the needs of end users. So these tools are mechanisms that can help us deliver and satisfy end user processing and service requirements. One of these tools is the Abnormal Job Termination Report. This basically identifies all programming jobs, application jobs that were finished before they were completed successfully. And it'll include any explanations or indication of termination conditions. Why would this happen? Well, the application was poorly designed, it was poorly developed or not tested at all. Operational instructions weren't provided, support wasn't provided, there wasn't adequate training or performance monitoring, improper system configuration, or inadequate capacity management. Another service level tool is the Operator Problem Report that's used by operators to log computer operation problems, challenges, and issues, and how they were resolved. These operator responses should be reviewed by the information systems managers or supervisors to decide whether these actions were appropriate or whether we need to do additional training to the operators. You've also got what are called output distribution reports. This will identify all application reports generated and where they were distributed to, the final location. These can be manual or they can be automatically created. And these are good for tracking lost, delayed, or misrouted reports. Console logs, another very valuable service level tool. Console logs can be created by servers, by networking devices like routers, switches, and multi-layer switches, including network-enabled appliances like firewalls, intrusion prevention systems. And of course, operator work schedules are very important as well. These are typically maintained by IS management, and these are going to help human resource planning. As an auditor, you need to make sure that you're auditing computer operators. These operators are responsible for efficiently and accurately operating scheduled computer jobs. Computer operators have to basically run macros, run applications, restart applications, back up computer files in a timely manner, monitor information processing, and monitor adherence to documented job schedules, participate in disaster recovery plans and tests, monitor performance, availability, capability, and failure of information resources, as well as facilitate troubleshooting and incident handling. An operator may also have to document instructions for tasks and procedures, procedures for rectifying machine and program failures, escalating unresolved failures, instructions for output report distribution, procedures for obtaining files to and from a library, reporting run delays, reporting and fixing equipment failures and job processing delays, and procedures for recovering archived files. An infrastructure operator is also responsible for automated unattended operations management. This is also referred to as lights out operation. These are tasks that would take place without human intervention. Tasks like console operations, job scheduling, balancing and distributing reports, mounting tape drives and management, managing storage devices, monitoring the environment, as well as physical and data security. Again, this is 24/7 lights out operation. An auditor has to also make sure that computer operations regarding input control and output control are in compliance with the IS management's goals, authorization, and overall intent. Operators may need to utilize job accounting applications, programs that match resource utilization with associated users for the purpose of billing, also optimizing hardware performance by changing software defaults or tuning system software defaults. And then finally, a big part of infrastructure operations is managing information system scheduling. This is typically done with job scheduling software. By using this software, the job information only has to be configured one time. This reduces potential errors. The job dependencies can be defined. Records are maintained of all job success and failures, and the reliance on manual operation is reduced. A program like Microsoft Project would be a good candidate for managing IS scheduling. Computer resources are a critical asset for most organizations, and as I promised in the introduction, we're going to go ahead and take a survey of a lot of different types of hardware in just a second, kind of a graphical survey. But as an auditor, you need to be able to identify and quantify computer resources like hardware, software, networks, telecommunications, and data. We're going to look here at just a kind of a little list of things that go into the resource monitoring that an auditor needs to make sure is in place in a company and organization. First of all, we have the process of incident handling. This is a critical IT service process. On a regular basis, you need to evaluate your organization to make sure that you have incident handling processes in place. Now, we're going to talk about disaster recovery later on in this Nugget series, but as part of resource monitoring, you want to make sure that you have methods in place to handle catastrophic failure of your computer devices, which means having system recovery, backup programs, even possibly stored images of the operating systems and applications stored up on servers. You also need some investigative process to provide an in-depth analysis when you have problems. Problem management is going to lead you to the cause of the incident, to the root cause of the problem. Full documentation to either prevent it from happening again, or if it does happen again, to get a quick resolution by going to the documentation. Incident handling and problem management are really kind of the same thing, but incident handling deals more with security-related vulnerabilities than problem management. As an auditor, you want to make sure that there's processes in place for dealing with anomalies, program errors, operator errors, network errors, system, telecommunication, hardware errors. You should have log entries that log the error date, error codes, error descriptions, the source of the error, when the issue was escalated to tech support, and the individuals responsible for maintaining the log and the log entries, as well as the department responsible for dealing with the anomaly. To audit the support staff or the help desk functionality of an organization or a business. Support and help desk entities are going to help end users find the source of computer problems and take appropriate actions. Typically, this technical staff will have a wide variety of templates that they can work from. That's why documentation of previous problems is so important, to create these flowcharts and step-by-step processes for troubleshooting. The help desk and support staff will initiate problem reports. They'll get detailed knowledge of operating systems and other system hardware. Obviously, they're going to provide technical support and help for a wide variety of users, including management. They're going to maintain documentation of the vendor's software, maybe tracking new releases and hot fixes and updates, possibly documenting in-house utilities and custom applications that are being used. The bottom line is they're here to service the user. You also want to have a change management process in place. This can be done, for example, through Windows 2003's group policy that's tied into Active Directory, establishing an IS management to control the flow of applications, the test environment, development, maintenance, ongoing testing, including things like migration and transition to new applications. That also ties into software control and release management. Ironically, releases in applications or upgrades to applications typically come from newer hardware, okay? You've got newer hardware capabilities, faster processing, more RAM, faster disk I/O, which leads to newer releases. Also to be able to have the device drivers to support new types of hardware components. So in addition to providing new software features, application releases are going to come because of hardware updates. And this is where resource monitoring comes in. Understand that in controlling software and releases, you're going to have what are called major releases, which is a significant change or addition to new functionality, or minor releases. A minor release is just going to be a minor upgrade, a small enhancement, or a fix. And then you'll have also emergency software releases. Typically, there's some kind of numbering system to this. For example, you might have major release 3.0, and then you'll have minor releases that come 3.1, 3.1a, 3.1ax, 3.2, and then finally the next major release would be 4.0. Well, perhaps you've heard of the A+ certification and the Network Plus certification, which go into great detail about hardware systems, networking systems, and the like. Well, the good news is, as an auditor, you don't have to really have A+ and Network Plus knowledge and beyond, but you do need to have a pretty good grasp of the different categories of hardware and networking components. So what we're going to do for the rest of this Nugget movie is kind of do a survey, and we'll have a lot of graphics to look at here, of different types of information systems hardware. Well, if you're going to look at information systems hardware, you might as well start at the core. No pun intended here. When it comes to your main system hardware component of a computer or a server, it is the CPU or the CPUs, the central processing unit. It consists of electrical circuits that control and manage all the operations in the computer system. It also performs mathematical and logical operations. Other key processing components would be random access memory, RAM, read-only memory, ROM, and things like that, as well as permanent storage devices. But really at the core, it's the processor. And of course, it never hurts to know, as an auditor, what type of processing needs the company has and what are their future goals for upgrading their processing on their servers, on their workstations, on their networking appliances. Now, that being said, also realize that processing can be added to other places besides the main board or the motherboard of a system. You're now seeing a huge push towards adding processors and processing to video cards and audio cards, network interface cards, modular cards for voice over IP, for encryption accelerators. Basically moving the processing to some of the peripherals and the modular devices to offload the overhead from the main central processing unit. For input-output components, this is a picture of my wife's keyboard. It's nice and pink. No, it's not mine. But input-output is, a wide variety of devices. You've got your keyboards, you've got your mice, but we're starting to extend now to other types of input devices. As a matter of fact, right now, I'm talking to you on an input device. An input device can also be a webcam sitting on top of the monitor. Here's a Wacom tablet, which is the kind I use to create these CBT nuggets with your own special input pin and input mouse. So a wide variety of different ways to pass information and instructions to the computer. Obviously, output devices come in a wide variety as well. The monitor, the speakers. A printer is an example of an output-only device. And maybe you've got an all-in-one device, which is a fax machine, a scanner, a printer, all wide varieties. You need to understand as an auditor the different type of peripherals that a company needs to have as part of their hardware management information systems. Here I am on a Saturday afternoon, slumming it with my input-output hardware system, my microphone, universal serial bus microphone, and my headphones, which is an output device. So there it is. Let's talk a bit about different classes of computers that can be categorized by a wide variety of different criteria, including processing power, their size, and the overall system architecture. What we're looking at here is kind of the top of the heap, and that's the supercomputer. These are really expensive, as you can see, very large. They have the utmost processing speed. They're designed to be used for special purposes or scientific fields that need a certain kind of processing power, like complex mathematical algorithms, calculations. These are specific, specialized systems or applications servers. Next, you have the mainframe. This was actually the kind of computer that I first worked on back when I was in college in the late 1970s. I actually had access. My first computer was basically the mainframe computer at the local university. These are large, general purpose systems that basically share their processing power and capabilities with thousands of internal users that are on thin hosts or monitors or external users. They can do multitasking very well, and they have an extensive range of capabilities. Typically, a mainframe has its own proprietary operating system that supports batch programming and real-time programming in parallel application. Historically, mainframes have been the main data processing and data warehousing tools for large organizations. Next, you have what's considered the mid-range server, mid-range computer. These could be blades. These are typically rack-mounted units, multi-processing systems that can support hundreds of simultaneous users. You could call these small mainframes. They're similar as far as memory management, segregation of workload, command languages, etc. These servers typically run Unix operating systems, Linux operating systems, Windows 2003. They're commonly used as database servers or application servers, maybe file and print servers. Next, you have the very popular microcomputer or workstation. This is a high-end workstation with multiple processors, a built-in array of disks, including read and writable DVD and CD players. This is running the new Windows Vista operating system, and this can support a wide variety of applications. These typically come with large, high-resolution monitors and graphics cards, typically 1 gigabyte or more of RAM, network interface cards with onboard processing as well as sound cards. These can be used for computer-aided drafting, gaming, wide variety of purposes. Sometimes you'll see these in what are called thinner versions, thin client computers, which are personal computers that have minimal hardware features and are really used to do most internet-based or web-based applications. Then, of course, there's the laptop or the notebook computer. This is a high-end Sony that's got all the features built into it. Typically, they weigh under 10 pounds. These are personal computers that are easy to move around, easy to transport. They can be powered by AC or rechargeable battery packs. All the high-end laptops are going to have similar CPU, memory, and disk storage capacity. But the cool thing is the battery pack makes it less vulnerable to power failures and a nice backup system built in. These are good for mobile users, telecommuters, teleworkers, and individuals who have to move throughout your campus or organization. Finally, we have these small handheld devices, commonly called PDAs. These are common computing devices that are about the size of a calculator or a little organizer. They'll include scheduling applications, phone and address books, tracking, creative applications, expense management, office features, maybe some automated features. They can be combined with computing, telephone, fax, and networking capabilities. They can be used anywhere, anytime. Some of these PDAs will be pin-based. They'll have a little pin that you use, or they can be used through a keyboard or the onboard keyboard. These PDAs can also interface with a PC or a laptop as a backup or transfer point, and these are also for mobile users, telecommuters, teleworkers, and just typically people on the go. You want to make sure as an auditor that these handheld devices and these laptops and wireless devices to go along with that are tightly managed and tightly inventoried. These have a tendency to show up missing and they're more vulnerable to threat and manipulation. Computers can serve a wide variety of roles, and basically any computer that has an onboard processor, disk space, and memory will be a server of some kind. It will be serving some type of service or application. But you can break down different roles into file servers. Computers or servers that kind of organize files and programs. In a large enterprise environment, these servers might have a large number of drive mappings where users could actually access rapidly changing documents on networked drives. All the data, of course, being stored in a file server or multiple file servers. Perhaps these file servers or Microsoft Exchange public folder servers. Regardless, these are used for management and document repository, for group collaboration, and document management. Obviously, print servers are going to serve up printing services to businesses of all different sizes. They can be distributed across multiple sites and multiple domains and service a number of printing devices. Application servers are basically giving users the ability to run applications not on their workstation, but in the client-server environment on an application server. In other words, the user won't have to install the program on their workstation or laptop. They can run the program off of the server. These are tightly grouped with web servers, which can provide the same type of service. Web servers obviously serve up web pages, but they can also serve up a wide variety of applications that use port 80. For example, multimedia, audio and video streaming, Java, VB script. These can be the corporate intranet servers or an extranet server for a strategic partner. Proxy servers are basically the intermediate link between a user and a resource. Often proxy servers are used so that internal users never really actually access the internet with their internal IP address. Everything goes through a proxy server. The proxy server can be used kind of as an application gateway or application firewall. It can also cache commonly used web pages and filter out certain applications that should or should not be used in the organization. There are a wide variety of proxy or application servers that are based on specific applications. And then, of course, database servers are typically used in a data farm. They perform as a storage unit for raw data or a raw data repository. These can leverage relational database management systems like Oracle or Microsoft SQL. Next, as an auditor, you should be aware of management systems and control systems that are going to monitor and maintain network-enabled appliances. What we're looking at here, and this is a little bit dark, I know this picture is, I apologize. This is actually the network rack in my lab, and I've got all different types of devices in here. You can see, you can't see all of them. I have several Cisco routers right up here, and sitting on top I have my what's called a management laptop. It's kind of my management workstation, and that connects to down below here. You can't really see it, but at the very bottom under this tray I have a Windows 2003 server, and on that server I've installed a wide variety of applications. My syslog server that I use for logging. I've got my AAA server in the form of a Cisco Access Control server for Windows, and it's installed on this little rack mounted, it's actually a big rack mounted server. It's a 2U, uses up 2 spaces. And then of course we've got routers, which are network layer 3 devices. They operate in that OSI layer 3, and I've got a number of them. I've got 2600 series, 2500 series. One of these is actually what we call an access server. I use this as my out-of-band management. So I connect from this actual laptop to this out-of-band access server, and I can basically use a console session. I can connect to all these devices. Below that, I've got 2 switches that are creating my network backbone. I can use these to create virtual local area networks. I can also get high-speed ether channel connections, and this is a layer 2 device. These are Cisco 2950 switches, and then below that I've got several other specialized appliances. Right below that I've got a Cisco VPN concentrator, and that's used for virtual private networking termination for site-to-site and remote access IP security virtual private networks. I've got a Cisco 515, PIX 515 firewall appliance that I use, and that firewall appliance operates at network layer 3, 4, and transport layer 5. So I'm covering all the different areas of the OSI model here, as my Windows server is operating basically at layer 5 through 7, the transport layer. Actually, layer 4 is transport, layer 5 is session. So I'm operating basically at all the upper layers on my server here. My PIX firewall, of course, providing those firewall, the stateful firewall purposes. And then below that, I've got my Cisco 3640 router, which is my high-end modular router that I use to provide a wide variety of services. And it has an operating system that has a kind of what we call a firewall security feature set on it, so I can use that as an intrusion detection, intrusion prevention sensor as well. So this is just an idea of all the different types of network devices you would see in a typical small to medium-sized business server room, and you should be aware of these types of devices as an auditor. You know, one thing you can do as an auditor to help the company lower its total cost of ownership is to master and leverage existing tools, existing built-in utilities on the operating systems. For example, Windows XP on the end user side or Windows 2000 and 2003 server have a bunch of tools already built in. For example, if I go to the Start menu, when I go to the control panel and I go to administrative tools, I'm going to see computer management. And one of the areas that you want to go to and be aware of that your company is using as an auditor is just the tools that are built in. The event viewer where you can go view the application and security and system logs. Again, this is where we do security auditing. This is where we do performance auditing for applications as well as system auditing. We can also use the performance area that allows us to do traces of particular performance metrics. I can also create alerts that go to email, for example. I can look at the device manager that allows me to go through and look at the different devices that are on this computer. Under storage, I have the disk defragmenter utility that I can use, and also disk management to manage your different disk partitions. If I go back to the Start menu, also, if I go to accessories here and I notice that I've got under system tools, I've got a system information here. And this is an area that you might want to leverage as an auditor or have each one of your IT supervisors or IT department heads go through and look at this area for system information. You can see that you can get a wide variety of information. This can be all sent to a database if you want to. This is all information stored in the registry of the operating system, showing all the hardware resources, all the components on the machine, the software environment, including system drivers and sign drivers, internet settings, office applications. And under tools here in system information, I've got several tools for system restoration, for network diagnostics, to verify file signatures, to make sure that you're using signed, secure applications. And one thing you might do, and this is this is going to be a pretty long file, but if you go and you print this out, you can actually print out this particular system information, and if you do, it'll print out in about, I don't know, about 100 pages. But this is one of those things that you might want to do for each one of your workstations. This is practical in a small to medium-sized business. Print this out for all of your workstations, staple it together, and put it in a file. Now, if you're using, let's say, imaging software to create identical images of all of your workstations, and you're kind of rolling those out to all of your clients, all of your end users, then you could really go and you could just print this 100-page or so document out one time and have all that information on hand, since all that's really going to change for these end user workstations are just personal profile look and feel type information. So this is something else you could do to have part of your audit program for computer management and system management. Use the built-in tools. Use the system utilities and computer management utilities that come free with the operating system, whether it be Windows or Linux or some other operating system like Mac OS. So in the big picture, as an auditor, you want to make sure that you have your finger on the pulse of the information systems hardware architecture and software as well. And this is all part of our IT service delivery and support strategy. We want to have our finger on all of the operating systems that are being used, make sure there's mechanisms in place to upgrade, to hot fix, to patch those operating systems. Access control software, maybe you're using an access control server for Windows solution for your authentication, authorization, and accounting services. Make sure that that's in place. Any data communication software that's being used. For example, are you using a VPN client like like Cisco's VPN client? Is that being installed on all the workstations and managed in a secure fashion? All the applications used for data management, whether it be a file system or database systems, or do you have a management plan in place for tape management and disk management for all your backups? What type of utilities are being used? Are those secure? For example, are they using Secure Shell instead of Telnet for their management access? And again, keep up with all your software licensing, and as an auditor, make sure that your organization is not using any pirated software, any illegal copies of software, that all the licensing is up to date. In IT Service Delivery and Support Part 2, we looked at four key areas: information systems operations, information system hardware. We talked briefly about some of the built-in hardware management tools on your operating system, and then finally the big picture: information system hardware architecture and software management. I hope this CBT Nugget's been informative for you. I want to thank you for viewing. We'll see you in Part 3.